Hi everyone. In this video, we are going to start doing the questions based on nature of roots. When we say nature of roots, they are directly related to the discriminant, right? We had done discriminant in the previous video. You can find the link attached in the description below. On the screen, you can see 8 questions. All the questions have appeared in the past year papers or they're highly important, right? But before we start doing the questions, let's have a quick recap on the discriminant. So first of all, discriminant was always referred by a capital letter D. It was equals to B square minus 4AC picked up from the quadratic formula, right? Now, there were 3 scenarios, 1, 2, and 3. The first one was if our D is greater than 0. That means the value of B square minus 4AC is greater than 0. In that case, the roots were real and distinct. Right? Real and distinct means they were different. Okay. Second case. Now, D equals 0. That means B square minus 4AC was equals to 0. In that case, the roots were equal. And the third, D is less than 0. That means B square minus 4AC is less than 0, right? So now that says our roots were unreal because according to the quadratic formula, the value of D is supposed to be substituted in the root and we cannot substitute a value which is less than 0, right? Now, based on this information, we are going to do the next 8 questions. So let's quickly start. The first question says, find the values of K. Do read this word carefully, values. Okay, values of K for which the equation x square minus 4x plus K equals 0 has distinct real roots. Now, when they are saying distinct real roots, so what do they mean? It means we have to go by the first condition, D is supposed to be greater than 0, right? So let's start working on it. We will write in case of distinct real roots, D is supposed to be greater than 0. Now, D means B square minus 4AC is supposed to be greater than 0. And guys, yes, when we are talking about distinct real roots or just real roots, you have to maintain the inequality. When we are not writing equation equals to between left hand side and right hand side, it is called as inequality. It is just going to be solved normally. Okay. Just see how we do it. Now, we are going to plug in the values of B square and B, A and C from the given quadratic equation. Now, what is a B? B is minus 4. Then minus 4 times A is 1 and C is K. It has to be greater than 0 as a precondition. So now we'll solve. Minus 4 square is 16 minus 4K greater than 0. What do we get? If it had been an equation, you would have just taken 4K to the other side. And we are going to do the same thing over here also. So 16 greater than 4K. That means 4 greater than K, right? Or you can read it as K is less than 4. The question asked, find the values of K. I did not get one value over here. Do not say that you have just got 4 as a value. No, 4 is not a value, but you have got multiple values because our K is something which is less than 4. So it has all infinite values which are less than 4. Understand this thing. Due to which the question says values. Just by looking at single 4, do not get confused that it is a single value. No. But the inequality over here is actually presenting you with infinite values. So what you will say at the end that due to the given condition, hence, in case due to, you can write due to distinct real roots our k is less than 4, due to which it is having multiple values. I hope this thing is clear, right? Now, moving on with the second question. The question over says, determine the positive values of k, emphasizing on positive values. Positive values of k for which the equation x square plus kx plus 64 equals 0 and x square minus 8x plus k equals 0 will both have real roots. Now, they are just talking about real roots. They are not talking about distinct real roots. These are different things. When we say distinct real roots, in the previous question, we understood that d is supposed to be greater than 0. But now, when they are claiming just real roots, that means they could be distinct, they could be equal. So we have to take a condition over here that d is greater than or equals to 0. Okay. Now, they are given two quadratic equations over here. So we will be finding two discriminants. And I will be doing that parallelly. Parallelly in the sense, I will be actually making a partition over here. Okay. And starting with the working for both of them simultaneously. On the left, I'm writing the first equation, x square plus kx plus 64 equals 0. And on the right, x square minus 8x plus k equals 0, right? We have to find two discriminants. So, d is always b square minus 4ac. Now, what is the condition? Will both have real roots. That means it should be greater than or equals to 0. But I am just finding d first, and the condition of real roots, I will use that later. And simultaneously on the right side as well. Okay. I am writing D2 and D1 to classify actually the discriminant for the first and discriminant for the second. So now plugging in the values, what do we get? We have B as k square over here minus 4 times 1 times 64. And similarly on the right side, we have minus 8 as B. So minus 8 square minus 4 times 1 times k. We plugged in the values from both the equations, right? What do we get? We get k square minus, now 4 times 64. That gives me, 6. And that gives me 256. And over here I get 64 minus 4k, right? Now, we have got two expressions on LHS as well as on RHS. We are being told in order to get real roots, d is supposed to be greater than or equals to 0, right? Because we have to find the value of k such that the quadratic equations have real roots, right? So now k square minus 256 is supposed to be greater than or equals to 0. And similarly, 64 minus 4k is also supposed to be greater than or equals to 0, right? So k square is greater than or equals to 256 and 64 greater than or equals to 4k. Now we are just going to solve them. So what do we get? We get k is greater than or equals to square root of 256 and 64 divided by 4 greater than or equals to k. Now, I told you, when we are solving inequality, you are going to solve it just like you solve an equation, right? So what do we get? K is greater than or equals to plus minus 16. Over here, it is just 16, right? Now, the question said positive values. The question said positive values, right? So that means we have to reject the negative value. Okay, so let's continue with this question on the next screen. That means my first value is supposed to be greater than equals to 16. I have rejected the negative one. And the second one said 16 is greater than equals to k. Now, just look at both the inequalities. On one side, we are having that k is greater than or equals to 16. And on the other side, we have k is less than or equals to 16. But we are supposed to find a common value. So therefore, k equals 16. Because if you see, what is common in both of them is actually that equals over here and equals over here. They both are actually pointing at 16. If I try to explain with the help of a number line, just look. This is 16. K is less than equals to 16 means I am moving over here starting at this point, right? Then K is greater than equals to 16. Again, I'm here, but I'm moving this side. So that means my K is nothing but 16. Okay. This explanation of number line is just for your reference, nothing to do with you, nothing to do in the paper or any test, but it is just for your mental understanding that how from these two inequalities we came to a common conclusion. Okay. Hence, the answer is 16. Now, okay. Now, starting with the third question. Question says, find the values of k for which 3k plus 1x square plus 2k plus 1x plus 1 equals 0 has equal roots. Also, find the roots. Now, we have got a condition that the roots are supposed to be equal, right? So, when the roots are equal, what is the condition for d? D is supposed to be 0, right? That means we will start for equal roots. D equals 0. That means b square minus 4ac equals 0, right? So now plugging in the values of b, ac carefully over here. Okay, what is b? B is 2 times k plus 1. I'm writing a square outside a square bracket over here. The reason being 2 and k plus 1 is a composite expression. So everything needs to be squared. Be careful with it. Minus 4 times a. Now what is a? A is 3k plus 1. And what is c? Thankfully it is just 1. Right? It is supposed to be equals to 0. Right? Now over here, be careful. 2 also needs to be squared. And k plus 1 also needs to be squared. Okay. So we'll start with it. 2 square means 4 and then k plus 1 whole square. Minus 4 times 3k plus 1. So I will expand the bracket, giving us minus 12k minus 4 equals 0. Right? In the next step, I'm going to expand k plus 1 whole square. What I will do over here, I will apply the identity of a plus b whole square. That gives me k square plus 2k plus 1 minus 12k minus 4 equals 0. Okay. So we get 4k square plus 8k plus 4 minus 12k minus 4 equals 0. Right? I can see 4 and 4 getting cancelled. So what are we left with? 4k square minus 4k. 8k minus 12k gives us minus 4k equals 0. So what do we get over here? I will have 4k as a common factor and that leaves me with k minus 1 equals 0. Right? Now it was a quadratic expression in terms of k. We got at the end a quadratic equation which is 4k square minus 4k equals 0. That means there should be two values of k. Since I have taken out 4k, doesn't mean that you will actually equate 4k with 0 and or you will just not do anything. No, you have to explore both the values. So that means 4k equals to 0 and k minus 1 equals to 0. We have to use both. So what does that gives us? It gives us two values, k equals to 0 and 1. We got two values of k, 0 and 1. Now, what was the question? The question was find the values of k. We are done with it, right? And also find the roots. But before we find out the roots, we have to plug in the values of k over here, right? Plugging in the k value over here means there are going to be two scenarios because we got two values of k. So let's start with the first case. case 1 when k equals 0, right? So the initial expression was 3k plus 1 x square plus 2 times k plus 1 x plus 1 equals 0. I keep my questions in front of me so that it becomes easier to refer. Now, I will plug in the value of k as 0 over here. That means I am getting x square plus 2x plus 1 equals 0. Because k is 0 over here, just left with 1x square. K is 0 over here. So 2 times 1 is 2x and plus 1, right? This is the simplest expression you can get in a quadratic equation because it is a plus b whole square, and over here we just get x plus 1 whole square equals 0. So that means we are getting the value of x as minus 1. There are two values, minus 1 and minus 1. This is your first case. Okay. Now, similarly, starting with case 2. When k is 1. Okay, when k is 1. So, I have the equation in front of me on the screen over here only. I will plug in the values directly in that. So, we get 3 plus 1 x square plus 2 times 1 plus 1 x plus 1 equals 0, right? What are we getting? 4x square plus 2 into 2, that is 4x plus 1 equals 0. This is the quadratic equation we got. 4x square plus 4x plus 1 equals to 0. It's a pretty easy equation. I suggest you can split it directly. But if you're fond of applying quadratic formula, the choice is completely yours. Now, solving it further, we had 4x square. So, I'm writing the equation just for your reference over here. Now, what we will do in order to split, we are going to multiply 4 and 1, giving us 4, and the factors become 2 and 2. So, 4x square plus 2x plus 2x plus 1 equals 0. Grouping, though I don't need to show these steps to you now being in class 10th, however, I'm still doing it. Taking out 2x as a common factor leaves us 2x plus 1 plus 1 outside, 2x plus 1 equals 0. So, 2x plus 1 and 2x plus 1 equals 0. That means, again, we have got same roots. See, remember the question. The question said equal roots. In the previous case also, we got x equals to negative 1. Now, over here also, we are getting x equals to minus half. Right? So, therefore, now the final conclusion. Roots of your initial equation. X equals minus 1 and minus half. It was a little longer question, but still I will say it is easier to do because we carefully solved first for k, which gave us two values, and from two values of k, we explored two cases, generated two cases by substituting each value carefully and found two equal roots in each of the scenarios, giving us the final answer as negative 1 and negative half, right? Such questions do come in boards. So do practice. Once you have seen the question in the video, pause it, go back to the question and do it again on your own, right? It will actually help you. Guys, whenever you are watching maths videos or even science numerical videos, do not just keep on watching it that yes, you have seen and you have understood. No, you may understand that just for a while, but when you start doing it after a gap, you may not be able to process it. You may not be able to repeat it properly. So after you have watched a video, in order to gain properly from that, do practice immediately. Then only it will help. That was the tip. Okay. Now, moving on with the fifth question. The question says, if the roots of the equation a square plus b square into x square minus 2ac plus bdx plus c square plus d square equals 0 are equal, prove that we have got a proportion over here that A over B equals C over D. This is what we are supposed to prove over here, right? So now it is again a little complex quadratic equation, but first you need to understand what all is your actually A, B, and C according to the standard form. Now, one more thing over here. In this question, they have used A, B, C, D, right? And the standard form also uses A, B, C. So what I'm going to do in order to differentiate, I'm going to write the standard form with caps. That means ax square plus bx plus c equals 0. We can modulate that, okay? Because we need to differentiate between the given ABC and the standard form ABC. Otherwise, while solving, while putting in, you may get confused and things may get wrong. Okay, now this complete thing is your A. And then starting from negative till this bracket is your B. And this thing is your C. Okay. Now, since roots are equal, D is supposed to be 0, right? So that means B square minus 4AC equals 0. See, I have used capitals over here, right? Now, plugging in the values. What was B? Minus 2 times AC plus BD whole square. This was our B. Minus 4 times, what was A? A square plus B square. And C was C square plus D square, right? Now, you need to expand this whole expression very carefully, okay? Because minus 2 square and AC plus BD square. So, starting with it. Minus 2 square gives you 4. And AC plus BD, it has to be a whole square. Means we need to apply the identity. And I will be doing that in the following step. Now, in the next part of the expression, what we have, I have to write equals to 0 as well, right? In the next part of the equation, what we get, you have to do binomial into binomial. That means term by term. Okay? So we'll do it carefully. A square, D square, A square C square plus A square D square, then B square C square, and the last B square D square. Right? Now, 4 times A square C square plus 2ABCD. It is actually in place of, if I have the identity of x plus y whole square, the middle term is 2xy. So it is 2 into x. X is AC, y is BD. So it is 2xy. Then B square, D square. Okay, got that? Now I will open up the second bracket, means I will multiply with minus 4. See, what I'm doing, it is just your basic algebraic expansions over here that are taking place. The only thing is you need to be careful. We clubbed it initially with some concept from quadratic. After that, what we are doing? We are doing what we learned in class 7th and 8th with respect to algebra. That is multiplication of binomial into binomial and addition and subtraction. There is nothing more in it, right? So expanding minus 4a square c square minus 4a square d square. I'm writing in the next line minus 4b square c square minus 4b square d square equals 0, right? Now we need to just move on to the next page. So we have to be careful. And when moving to the next page while taking your exam, while writing your paper as well, please be careful, because many a times children do commit mistakes while when you move from one page to another in copying the content from the previous page to the next page. Okay. So what we get over here is 4 times a square c square plus 8 ABCD. We had to multiply 4 with inside. So plus 4b square d square. This was the first bracket, right? The second bracket gave us minus 4a square c square. It is a very bigger expression to copy down actually. Minus 4 a square d square minus 4 b square c square, and the last minus 4 b square d square equals 0, right? So what are we getting? See, we can cancel out things. A square c square positive negative, then b square d square positive negative, right? What are we left with? 8a b c d minus 4 a square d square minus 4 b square c square equals 0. We are just left with this one, right? Okay. Do we have anything in common except 4? No, we do not have. So what are we left with? I can take out 4 as a common factor, leaving us with 2abcd minus a square d square minus b square c square equals 0, right? So now what we are getting, see, we have got two factors. The first factor is 4. The second factor is the full bracket. We can just ignore 4, and from here, therefore, we can write 2abcd minus a square d square minus b square c square equals 0. Guys, we need to be very careful at this step. And I understand this step is actually confusing when you are doing for the first time. So now what I'm going to do, I'm going to take out a minus 1 common. Why am I doing that? You will realize it soon. When I take out minus common, it leaves me with minus 2abcd plus a square d square plus b square c square equals 0, right? This is what we get. Now, what we have? We have got, I just ignore the minus that's going to 0. So we get a square d square minus 2abcd plus b square c square equals 0. And see what I'm going to write now. AD whole square minus 2AB, or I should write AD BC plus BC whole square equals 0. I'm sure this last step can actually give you a hint that what we are actually moving towards to, right? Because the working for this step started right over here when I used just the second bracket. So what are we getting? We are getting AD minus BC whole square equals 0. We factorized. That said, we are getting AD minus BC equals 0, right? So AD equals BC. And from here, what can I get? I can write A over B equals C over D, hence proved. I really like writing hence proved a little bigger when we have done a long question successfully, right? So see what we have done. We started with a good long quadratic equation. Using d equals to 0, we substituted the values in b square minus 4ac, right? Evaluated a bigger expression, simplified it, and then again to solve it, we factorized by applying the identity of a minus b whole square, and we got the desired proportion, right? Now, moving on with the next question and see how big these questions are. And they all have appeared in past year papers. Now, moving on with the next question. 6.1. If the equation 1 plus m square x square plus 2mcx plus c square minus a square equals 0 has equal roots, then prove that c square equals a square times 1 plus m square, right? Now, again, we have equal roots. So you can see whenever you are having such big questions, there is same condition every time, equal roots, because you are able to equate an equation with 0 and it becomes easier to solve, right? Okay, now, so we have equal roots, means d is supposed to be 0. And again, this question is using C and A. So I will be using capital B, A, C in order to describe my discriminant. So therefore, B square minus 4AC equals 0. So substituting the values now. What is B? B is 2MC, right? This is what we get. Minus 4 times A. A is 1 plus M square. And C is C square minus A square. It is supposed to be equals to 0. We are just going to simplify things. It gives us 4M square C square. And guys, if you are getting a hint that how you need to perform this question, you can pause the video here itself and try to do it. After doing, you can verify that whatever you did is matching with the working and you can be happy about it. Then I'm going to expand the brackets binomial into binomial. So we get C square minus A square plus M square C square minus M square A square equals 0, right? So we have 4M square C square minus 4C square plus 4A square minus 4M square C square and plus 4M square A square equals 0. And over here, I can see my M square C square is one positive, the other is negative, right? What are we left with? Minus 4C square plus 4A square plus 4M square A square equals 0. We can easily take out 4 common, leaving us with minus C square plus A square plus M square C A square equals 0, right? So obviously, as per the given expression, which is C square equals to A square, brackets 1 plus M square, I don't need this 4, right? So now, moving on to the next page, I'll directly write minus C square plus A square plus M square A square equals 0, right? The desired expression was C square on one side. So I will take this C square to the other side, right? That gives me A square plus M square A square equals C square, right? A square is out. I'm left with 1 plus M square equals C square. I think it was the desired expression. See over here. C square equals 1, C square equals A square brackets 1 plus M square. And this is what we get, right? So we will happily conclude, hence proved. The questions many times may appear longer by looking at the quadratic equation, but they may not be that long if you do it properly and carefully, right? Now, the 7th question. If the roots of the equations ax square plus 2bx plus c equals 0 and bx square minus 2acx plus b equals 0 are simultaneously real. Simultaneously real means they both are real. Okay. We are supposed to prove that b square equals ac. Okay. Now what we have? We have got 2 quadratic equations over here, right? So what are we supposed to do? We are supposed to find the value of d from each of them. And simultaneously real means d is supposed to be greater than 0. So let's start doing it. Okay. Now, real roots means d is supposed to be greater than 0, right? They have just said real. They didn't say about distinct, but they just said real. So I'd say d is greater than equals to 0. Okay. Now, from the first equation, what we have? Ax square, that means we need to find 2 d's, d1 and d2, right? Let's segregate once again. So what do we get from the first one? We have, it is supposed to be plus, we get 2b whole square minus 4 times ac greater than equals to 0. And now the second one, what do we get? Minus 2 times under root of ac whole square minus 4 times b greater than equals to 0. This is what we have, right? So we are just going to plug in the, we are just going to simplify now. 4b square minus 4ac greater than equals to 0, right? The right one, the right expression, what does that gives? 4 times AC, because we have to do a square of under root, and that that actually negates void, right? Square root and square are getting void, so we are just left with AC minus 4 b square greater than equals to 0. So 4 is a common factor in the first expression, leaving us with b square minus 4ac greater than equals to 0. And similarly, 4 is a common factor in the second expression also, leaving us with ac minus b square greater than equals to 0, right? Now, it is quite similar to one of the initial questions we did today, where we had a similar expression where d1 and d2 both were coming as 16, but one of the d's were greater than equals to 16, the other d was less than equals to 16. I explained through the help of a number line also that why the value was 16. So over here, we have to use a similar concept. The difference between these two questions is in that you had a satisfying numerical value. Over here, we have got an algebraic expression, right? But the concept remains absolutely same. So what are we doing? Now, it says b square minus 4ac greater than equals to 0 and ac minus b square greater than equals to 0. So basically, what do we get? Therefore, b square minus 4ac is equals to 0. Hence, b square equals 4ac. Sorry, just a moment, my bad. It was not supposed to be 4 over here, right? No 4s. 4 were already out, right? So we had to write a over here. So b square equals ac, and that is what they had asked. What we can do? Just final words. Hence, proved. What I did, I ran two simultaneous values for t, discriminants, and proved using the inequalities that yes, b square comes out equals to ac, right? Okay, now the last question. If the roots of the equation, again a bigger one, c square minus ab, that is x square minus 2 times a square minus bc x plus b square minus ac equals 0 are equal, then prove that we have two conditions. Either a equals to 0 or a cube plus b cube plus c cube equals 3abc. Now, there are two things which we are supposed to prove, but the main condition is same that we have been doing since long. The discriminant is equals to 0 because we have got equal roots over here, right? So let's start. Equal roots, that is b is 0, right? So I'm using capitals. B square minus 4ac equals 0. Now what are we supposed to do? Plug in the values carefully. Okay, so what is b? Minus 2 times a square minus bc whole square minus 4 times c square minus ab. Then c, what is c? B square minus ac equals 0, right? Carefully expanding now. Minus 2 square is 4. A square minus bc whole square minus 4 times. Okay, what do we get now? We have to solve again a binomial into a binomial. So c square b square minus ac cube. C square is getting multiplied with ac. So we get ac cube. Then minus ab cube because ab is getting multiplied with b square plus. Now the last is ab getting multiplied with ac. So that gives me a square bc equals 0. Okay. In this step, what I'm going to do, I am actually going to take out this 4 common here itself without wasting a step in expansion, and then after that taking out I'll just take it out over here also. Now, 4 is taken out. Simultaneously, I will expand a square minus bc whole square. So that gives me a4 minus 2a square bc plus b square c square. And along with that, I will expand the second bracket using the negative outside. So that gives me minus c square b square plus ac cube plus ab cube minus a square bc equals 0, right? This 4 outside will go to 0 and it is useless for us. And also along with that, what I'm going to do, I'm going to see what do we have, which terms which can be cancelled out. And I can see b square c square is the term which was getting cancelled. And we have 2a square bc minus a square bc, which is like term, right? That means we can simplify. Now, moving on to the next page. That gives me a to the power 4 minus 3a square bc, right? Plus ac cube plus ab cube equals 0. This is what we are getting, right? Okay. Now, what can we see from this expression? I have got a as a common factor present in all the terms, right? So taking that out gives me a cube plus c cube plus b cube minus 3 abc equals 0. And now we are very close to our final answer. That means I'll equate both the factors with 0. So a equals to 0 and a cube plus b cube plus c cube minus 3abc equals 0, right? That means from the second we get a cube plus b cube plus c cube equals 3abc. The first was a equals to 0 and therefore hence proved, right? So guys, in this video, we did good long 8 questions. I had picked it thoroughly by selecting from the past year papers and the important ones based on the nature of roots. We did all the variety where we talked about distinct real roots, we talked about real roots, we talked about equal roots, right? Yes, none of the question was around unreal roots because that question hardly appears with respect to variables. And my focus was on the longer questions which are tougher to expand and solve. So over here, I have solved each and every question carefully for you. Do watch the video, pause, and as I've been telling, pause, practice, and do visit it properly so that you can gain the knowledge out of it, right? And in case you have any doubts, you can always comment. Happy learning!